Good morning guys. Today we'll be dealing with some of the problems regarding plane angle as well as solid angle. It's okay if you find it very tedious guys, but without numerical problems there is no physics. So what would you do? Repeatedly hear the videos until and unless you understand the numerical problems which we are going to deal. So first we will start with a small problem. I'm not writing the entire problems here because these type of problems which we are going to discuss is actually theory based questions. Only numerical section means numbers is written, but it is actually theory based, so you have to grasp the basic of it. That's why I'm going to do it. Okay, and the first question is, suppose there is a child or a boy who's moving in a circular path and he moved from point A to B, and he's moving with a velocity of say 5 meters per second, and it is happening in the time period of 3 seconds. Right, he's moving from A to B. Here, what is the angle subtended by this person at the center? That is theta. You're asked what is the value of theta if it's moving from A to B. Now that is a question here, right? And this much parameter is given. So how would you calculate what has been taught to you guys? This is a plane angle. So this theta is equal to arc length AB by radius R. Right. So now say radius of this path is given as 100 meter. Say that is also given. Right. Now how would you calculate this value? Now what is AB? This is arc length. Right. So that is not straight away given to you guys. Right. But length is velocity into time. Right. Divided by R. Now what is velocity into time? 5 into 3, that is 15. And what is the radius? 100. So it is 0.15 theta, right? Theta is in radian. So 0.15 radian is the answer. Now question I am going to change. You are asked what is the angle subtended per second by him. What is the angle subtended by the person per second at the center? That means in place of theta, you are now asked what is theta by t. Right. Now for 3 seconds, he is subtending an angle of how much? 0.15 radian. So for 1 second, how much will be the angle subtended by him? 0.15 divided by 3, that is equal to 0.05 radian what? Per second. Right? Clear? This theta by t is known as angular speed in your rotatory dynamics, which you will learn in later on classes or later on chapter. So omega is theta by t. Now there is a short formula which you can use by removing this intermediate step. That is, see, omega is theta by t. Now theta is L by R, remember. Now L can be written as V into t, distance. So t dt cancel, or I can write omega is equal to V by R. This is a short formula which you can by heart as it is. Clear? Right, this formula you will learn later on classes. I just introduced. Need not worry if you didn't understand this concept. Understand this much concept. This is only required in your chapter. Clear? Now there are different next type of question which you have to understand is, you will be asked, there is a solid sphere like this. Right, and the question is, what is the angle subtended by this solid sphere at its center? What is the angle subtended by this solid sphere at its center? Now these type of questions, how will you deal? You will consider that in place of this solid sphere, you see this solid sphere means the angle subtended will be solid angle, that is omega. So this angle I want to know, this is omega. Right, so how would you calculate these things? You have to consider another solid sphere as a screen here, and consider there is a light source placed at the center. Right, now this light source, when it turns on, will be providing light to the entire section, right, like this. So from this section of the inner sphere, a shadow will be produced over this side. Similarly, there will be multiple shadows, and the entire shadow will be throughout the surface area of this outer screen sphere. Right. So the angle, solid angle is, question is area by r squared, remember. Now r is the radius from this point to this, let's say that is r. Now what is the area? Area of the outer sphere or the screen where the projection is happening. Now that area, surface area of a sphere is 4 pi r squared divided by r squared, and the angle is 4 pi. This is something you have to by heart or understand. This angle subtended by a solid sphere at its center is always 4 pi. Clear? Now suppose I replace the solid sphere with the hemisphere. Suppose the question is like this. I am having a hemisphere. Right? Similar process I will happen. The center is, see what is the angle projected by this hemisphere at its center. That is, you are asked what is this angle. Right, again by the previous process I will keep a screen which is also a sphere. Right, and this is in steradian, right? I hope remember. Right, now this solid is having hemisphere surface, and this is a source light. Again the light goes on, but this light in this much area is straight away falling on the screen without any hindrance, so no shadow here. But the light from this source, when passes through this solid surface, this much portion will be getting what? Shadows. Right. So outer spheres, how much portion is getting our shadow? Only this much portion, or I can say only half the part, or I can say this now. Right. Steradian, area by r squared. Area is only half the part, which is 2 pi r squared by r squared, or it is 2 pi steradian. So hemisphere is only subtending an angle of 2 pi steradian at the center. Clear? Now again I am going to change the question. In place of sphere or hemisphere, we are going to replace it with a cube. Right? This is our cube. Sorry guys if it doesn't look like a cube. And this is the center, C. Again your question is, what is angle subtended by the cube at the center? So again, just like the previous case, I will consider a outer screen which is spherical in shape. Right, from this point, see, I'm going to produce a light source. So the light will be moving throughout, right, like this throughout. And the shadow will be on the spheres completely. Just like the previous, this one case, right. So the entire surface, so again, steradian angle, solid angle is area by r squared. Area is of this surface, of the cube or the screen, of the screen. So 4 pi r squared by r squared. Let's say this is the radius r. So this is 4 pi steradian. So a cube also subtends an angle of 4 pi steradian at the center. It's a very, very important point. Clear? Because it's a three-dimensional surface. Three-dimensional surface always be considered in a spherical form. It's better to consider a closed surface like this. Clear? Now again I can ask a simple twisted question with this point itself. What will be the angle subtended by each face? Each face. What will be the angle subtended by each face of the cube? How will you calculate the angle subtended by each face? But the entire cube, the angle subtended is 4 pi steradian, means how many faces are there in the case of a cube? There are 6 faces. Right, and 6 faces totally is subtending an angle of 4 pi. So one face will be subtending how much? 4 pi by 6, or I will say 2 pi by 3 steradian. Clear?